Hello everyone, welcome to my channel Tales of Chemistry. Today we are going to learn Standard 10 icse Chemistry, Chapter 7a, Hydrogen Chloride and Hydrochloric Acid, in that chemical properties of dilute hydrochloric acid. Now, the first point that we all need to keep in mind is hydrochloric acid is a typical acid, dilute hydrochloric acid. Let me be very specific. Dilute hydrochloric acid is a typical acid. Now, what does that mean? It means dilute hydrochloric acid shows all the properties of acids, like it will turn blue litmus red. It will be sour in taste. Moreover, it undergoes all the chemical properties like neutralization. Neutralization is a most typical behavior of, dilute acids, right? So hydrochloric acid can also undergo neutralization reaction. Now, let us see what more is there in syllabus. First point is it is a typical acid. Second point is it is a monobasic acid. Now, hydrochloric acid is a monobasic acid. Let us look at this. HCl on dissociation gives us one H plus ion and one Cl minus ion. The same thing can also be written HCl when dissolved in water produces just one hydronium ion and one Cl minus ion. Now, this is the property which is helping us to conclude that it is a monobasic acid. On dissociation, HCl will produce just one H plus ion or just one hydronium ion. So any acid which produces only one H plus ion on dissociation is called a monobasic acid. All right, so these are the two properties. Now, there are certain chemical reactions that we need to study. They are classified into several categories. The first one is its reaction, dilute hydrochloric acid's reaction with the metals. Though I have written metals here, I mean active metals only. Active metals are those metals which are above hydrogen in the metal activity series. So let's pick some examples. Zinc is an example. Then, iron is an example, Fe. Then Mg is another example. I have randomly taken just 3 active metals. Now, when you write the equation, it's compulsory to mention the acid taken as dilute. So, Zn plus HCl dilute gives you the corresponding salt. What will be the salt here? You can easily understand. Zn and with HCl, there is only one salt that is possible, which is ZnCl2 and H2. Now, what is the physical state of H2? Hydrogen is a gas. So that's what written here in bracket. Similarly, Fe, I forgot to balance this. Zn plus 2HCl. Every equation has to be balanced. Now, Zn plus 2HCl gives you ZnCl2 plus H2. Equation is perfectly balanced. Now, moving on to Fe. Fe, sometimes students think that it has variable valency. Fe2 plus is there, Fe3 plus is also there. Which one should I write? Isn't it? Here, it is always FeCl2. FeCl3 cannot be prepared by this method. Ferric chloride cannot be prepared by this method. So directly, if you are dropping the metal in hydrochloric acid, the salt that you get will be ferrous chloride only, along with hydrogen gas. Okay, third equation. Mg plus, here also, hydrochloric acid dilute gives MgCl2 plus H2. So, commonly asked metals I have covered here, zinc, iron, magnesium, or even if it is calcium, you will write the equation the same way. That is, metal plus dilute hydrochloric acid gives us salt plus hydrogen. So that has to be our conclusion here. Any active metal, okay, any active metal, when it reacts with the dilute hydrochloric acid, the products are corresponding salt plus hydrogen gas. Now, in the 10th standard board examination, they always ask one question. Name the gas evolved and suggest a chemical test for the gas. So it becomes compulsory here to learn a test, okay, for hydrogen. Now, when the question is suggest a test, you cannot write observation. Some students, misunderstand the question and they just write that it is a colorless, odorless gas which is evolved. Right? Colorless, odorless gas is just the observation. Test for hydrogen, if asked, you should write, definitely you can write it is a colorless, odorless gas which burns with this is the test, which burns with a blue flame. Even for observation, you can write the same thing, blue flame. Okay, then continue. A burning matchstick or a splinter can be written. When comes in contact with this particular gas, it extinguishes. It extinguishes with a pop sound. So if a test for the gas is asked, or even if observation is asked, do not write just colorless, odorless gas. Complete it. Colorless, odorless gas which burns with a blue flame. And if a burning matchstick, brought in contact with this gas, it extinguishes with a pop sound. So I hope the first set of reaction is very clear. That is reactions of metals with dilute HCl. Second chemical property that we should study here. Okay, second chemical property that we should study here is a reaction of metal hydroxides or metal oxides with dilute HCl. Okay, then let me take any two metal hydroxides and two metal oxides as well. Say, for example, NaOH is a metal hydroxide. MgOH twice is a metal hydroxide. Regarding oxide, I can take copper oxide. Yeah, so, or maybe one more, sodium oxide. So I have taken two hydroxides and two oxides. This hydroxide, when treated with dilute HCl, so previously I have told you it is compulsory to write dilute below HCl. The products are salt, Na and Cl, NaCl, salt plus water. The products are salt and water. Okay, then the next reaction is with magnesium hydroxide. Magnesium hydroxide and HCl dilute gives us MgCl2, magnesium chloride, MgCl2, okay, plus water, MgCl2 plus water, MgOH twice plus balancing requires 2 HCl because here Cl2 is there. So we better take 2 HCl, which makes the total number of hydrogens 4. 2 hydrogens here and 2 hydrogens here. So totally 4 hydrogens. I should write 2H2O, isn't it? So the second equation is also balanced. Now, so here we are concluding that hydroxide and hydrochloric acid are giving us salt plus water. Salt plus water. Let's see what are we getting in the case of copper oxide and sodium oxide. Copper oxide, when treated with dilute hydrochloric acid, look at this, you will be getting CuCl2. Okay, copper also has variable valency. Here the product is not CuCl, but CuCl2. Keep that in mind. So you will again require 2 HCl and the byproduct along with the salt, you are getting water. Then last equation with the sodium oxide. Sodium oxide and HCl dilute gives us the salt, sodium chloride as well as water. So, whether it is a hydroxide or metal oxide, your products remain the same. That is corresponding salt plus water. Yeah, no gases are released here, so they cannot ask a question. Suggest a test for the gas here. It is just salt and water. So what is our conclusion here? The conclusion here will be, metal hydroxide or oxide, metal hydroxide or oxide with dilute HCl, when treated with dilute HCl, gives us salt, the corresponding salt plus water. Yeah, I hope even the second reaction you all have understood clearly. Then, next, this is the third chemical reaction that we needed to study is reaction of metal carbonates or bicarbonates with dilute HCl. Reaction of metal carbonates or bicarbonates with the dilute HCl. Alright, so let me pick any two carbonates. Say maybe Na2CO3 sodium carbonate and calcium carbonate. Okay, now this has to be treated with HCl, compulsory to write dilute. The products here are definitely salt, NaCl, water, and a third product is obtained, which is carbon dioxide. All metal carbonates with dilute hydrochloric acid will give us the corresponding salt, water, and carbon dioxide gas. Now, balancing part. Two NAs are there, isn't it? Na2. So straight away, let me write 2 NaCl. When I do this, I'm disturbing the number of fluorine atoms. Therefore, let me write 2 HCl here, which makes it H2O, correct? And 1 carbon dioxide. So the equation is properly balanced now. Moving on. With calcium carbonate and hydrochloric acid, salt, calcium chloride, CaCl2. This we should know. When is it NaCl? When is it CaCl2? Yeah, the difference we must know. The valency chart of 8th or 9th standard we must know properly. Then water and carbon dioxide gas. Check whether the equation is balanced. 1 calcium on either side. 2Cl, yes, chlorine is balanced. Hydrogen, carbon, oxygen, everything is balanced. Now, what should I take? Some bicarbonates. Let me take probably Mg, HCO3 twice. This is magnesium bicarbonate. Now, in magnesium bicarbonate, when you treat it with dilute hydrochloric acid, you will get the corresponding salt, which is MgCl2. MgCl2 plus H2O plus CO2. So, salt, water and carbon dioxide. Salt, water, carbon dioxide. Alright. So, let's try balancing this. 1 Mg on either side. Chlorine, you have only 1 chlorine on the left side, but 2 chlorines on the right. So, just write 2 HCl, which makes the total number of hydrogens 2 plus 2, 4. So, I must write 2H2O here. Now, carbons 2 on the left side, now 2 on the right side. Only thing we need to check is the oxygen. 2 into 2, 4 plus 2, 6. Here 3 2s are 6. So both sides there are 6 oxygens also. Equation is perfectly balanced. Now, what will be your conclusion? Whether it is metal carbonate or bicarbonate, metal carbonate or bicarbonate, when treated with dilute HCl, give salt, water and carbon dioxide gas. Now, since there is a gas here, you can expect the question, suggest a chemical test for the gas. Yeah, which gas is evolved? Suggest a test for the gas evolved. Test for CO2 as it is a colorless, odorless gas that turns lime water milky. It is a colorless, odorless gas that turns lime water milky. Now, you may remember that even sulfur dioxide turns lime water milky. Okay? But you are still safe here because you have written colorless, odorless gas. Sulfur dioxide has its own peculiar smell, but carbon dioxide has no smell. Still, if you want to be extra careful, you can also write colorless, odorless gas that turns lime water milky, or you can even write the same thing as a colorless, odorless gas that does not decolorize dilute acidified potassium permanganate solution. So either write that turns lime water milky, or you can write that does not decolorize dilute acidified potassium permanganate solution. So one extra test I have given, whereas the first one is perfectly all right. Colorless, odorless gas that turns lime water milky is perfectly all right. Okay, so 3 reactions we just studied. I hope you have understood all the 3. Fourth reaction is metal sulfides. Bisulfides are not in syllabus. So reaction of metal sulfide with dilute HCl. Reactions of metal sulfide with dilute HCl. In this, let me take Na2SO3 or MgSO3. So 2 sulfides are taken. Any sulfide of your choice can be taken. Even CuSO3 can be taken. Now, when this is treated with HCl dilute, this gives us the corresponding salt, NaCl, water, and sulfur dioxide gas. Carbonates were giving us carbon dioxide gas. Sulfides are giving us sulfur dioxide gas. So Na2SO3 plus 2HCl. Right? Why did I write 2 here? So as to balance the chlorine on the right side. Na2 was there, so it was compulsory to write 2 NaCl, which made the number of chlorine 2. So on the left side, I've written 2 HCl. That helped me in balancing hydrogen, right? And SO2 as well. So we are done with balancing. Second equation. MgSO3 and dilute hydrochloric acid gives you MgCl2. Magnesium chloride is MgCl2 plus water plus sulfur dioxide. 1 Mg, 2 chlorines on both sides, 2 hydrogens, 1 sulfur and 3 oxygen. So this equation is also balanced. So what is your conclusion here? Metal sulfides react with dilute HCl, dilute hydrochloric acid, to give salt, water, and SO2 gas. And whenever we see the gas, we must understand that there is a possible question, suggest a test for the gas. So for sulfur dioxide, this is also a colorless gas. Okay, but it's not odorless. It has its own characteristic smell. So you can write suffocating, colorless, suffocating gas, or you can write colorless, burning, sulfur smelling gas. Gas with burning sulfur smell. Okay, that turns lime water milky. So compare the previous one, that is the test for carbon dioxide, with the test for sulfur dioxide. Over there we have just written colorless, odorless gas which turns lime water milky. Here we are writing colorless, suffocating, odored gas, which turns lime water milky. Or even you can write that potassium permanganate one. Here SO2 decolorizes dilute acidified potassium permanganate solution. Previously we have written which does not decolorize, but in this case it decolorizes. Yeah, this particular gas will turn pink colored or purple colored potassium permanganate to completely colorless. So that's what we mean by which decolorizes. Okay, now one more reaction. A reaction of metal sulfides with dilute HCl. Reaction of metal sulfide with dilute HCl. This is a very frequently asked question. One question from this is definitely coming for the board examination. What are metal sulfides? What are some common examples for metal sulfides? PBS, lead sulfide. Okay, lead sulfide. FES, iron sulfide, or CuS, copper sulfide. In all the sulfides, the metal is in its +2 valency. All these are metals having variable valency. So if you want to know the name, this is lead 2 sulfide, iron 2 sulfide, copper 2 sulfide. So any of these sulfides, when treated with HCl, dilute hydrochloric acid, you are getting PbCl2. You are getting PbCl2, that is the corresponding salt, plus H2S. No more water, etc. Now directly you have got H2S, hydrogen sulfide. Hydrogen sulfide. Then FeS plus 2HCl, same way, dilute hydrochloric acid, FeCl2, iron 2 chloride, ferrous chloride, plus H2S, hydrogen sulfide gas, finally with copper sulfide and hydrochloric acid dilute gives you CuCl2 plus H2S. Now, here observation if asked. Observation will be rotten egg smelling gas. H2S is having a rotten egg smell. A rotten egg smelling gas is evolved. So if the question is observation, you can just write rotten egg smelling gases evolved. But if the question is suggest a test, okay, you have to write, you cannot just write rotten egg smelling gas. You have to write a gas which turns lead acetate paper or lead acetate solution. Lead acetate solution or lead acetate paper black is obtained. Okay, so it's better to write moist lead acetate paper, those who are writing paper, not a dry paper, because if both the gas and the paper are dry, the reaction may not happen. So moist lead acetate paper, wet lead acetate paper will turn black by H2S gas. All right. So some of the chemical properties we have completed. There are 2 more chemical properties of dilute HCl that we need to study. That will be done in the next video. So thank you all. Stay tuned.